and very welcome. And now we are running our module course on basics of electricity. And today's special is we will understand how to add or connect capacitors in series and in parallel. So first thing first, we talk about capacitors in series. You can see that there are range of different types of capacitors available in the market. This is called ceramic capacitors. This is called electrolytic capacitors. But now we'll see how their connections in series and parallel behave. So for example, you have two capacitors, C1 and C2. They are said to be connected in series. So in this case, their equivalent capacitance or net capacitance can be calculated as 1 over C equivalent, where C equivalent is the equivalent capacitance of this network. That is equal to 1 over C1 plus 1 over C2. Therefore, we see the C equivalent will be equal to 1 over this term. So basically, C equivalent is the reciprocal of the terms of the term that is shown right over here. How about there are n number of capacitors connected in series. For example, starting from C1, C2, up to Cn minus 1 and finally Cn. So if there are 10 capacitors in series, it means this is number 1 capacitor, this is C2, this would be 9th and this would be the 10th capacitors. In this case of this network, the equivalent capacitance will be calculated or given as 1 over C equivalent, that is equal to the reciprocal of all the capacitances that shown over here. That is 1 over C1 plus 1 over C2 plus up to 1 over Cn minus 1 plus 1 over Cn. And therefore, we will write C equivalent will be equal to 1 over this term, this whole term. So basically, C equivalent of this network will be the reciprocal of this term. How about capacitors in parallel? So we will see when the capacitors are connected in parallel, how to determine the equivalent capacitance, or in other words, net capacitance. So here is the network. We see that C1 and C2 are connected in parallel because both the ends of C1 and C2 are connected at the same node. That's why they are said to be connected in parallel. In this case, we talk about calculating C equivalent. So simply C equivalent is equal to C1 plus C2. It is same as you add the resistors in series. How about there are n number of capacitors connected in parallel to each other. For example, C1, C2, up to Cn minus 1 and Cn. So if there are 10 capacitors, so this would be C1, this would be C2, number 2 capacitors, and this would be the 9th capacitor, and this would be the 10th capacitor. In this case, C equivalent would be simply the sum of all the individual capacitors connected in parallel. That is C1 plus C2 plus up to Cn minus 1 plus Cn. Now let us have some examples with the real world values of the capacitors. For example, you are given series connection of two capacitors C1 and C2, and each values of these capacitors is 1 microfarad. In that case, as we have seen that 1 over C equivalent equal to 1 over C1 plus 1 over C2, and therefore we know that C equivalent is the 1 over this term right over here. So we will just plug in the values of C1 and C2 right here, and we see that therefore C equivalent is equal to 1 over this term now, 1 over 1 microfarad, that is the value of C1, plus 1 over 1 microfarad, that is the value of C2. So therefore, we know that C equivalent is equal to 0.5 microfarad. How about same values of the capacitor, that is C1 and C2, 1 microfarad each, but now these capacitors are connected in parallel and we want to know the C equivalent. So it is as simple as C equivalent is the sum of individual capacitors value. Therefore, C equivalent is equal to 1 microfarad plus 1 microfarad, that is equal to 2 microfarad. If this C1 is, let's say, 1 microfarad and C2 is 2 microfarad, the net capacitance would be 1 microfarad plus 2 microfarad, that is equal to 3 microfarad. So this is how you can calculate the equivalent capacitance of a network connected either in series or in parallel. Similarly, you can try C1 to be 1 microfarad and let's say C2 is equal to 2 microfarad. Just put in those values right over here and you would see what is the value of the C equivalent. Now, how about when the capacitors are connected in serial and parallel combination? For example, you can see this network here. C1 is connected in parallel combination. C1 is connected in series with the parallel network of the C2 and C3. So we see clearly that C2 and C3 are connected in parallel with each other and C1 is in series of this network. So each of these capacitance values are given here. C1 is 1 microfarad, so is the C2 and so is the C3. Now, equivalent capacitance of this network, as I said before, is equal to C1 plus, in parenthesis, C2 in parallel with C3. So you see that this is a parallel network of two capacitors, C2 and C3. Therefore, we first calculate the equivalent or net capacitance of this network, which is simply the sum of C2 plus C3. And we know that the values given of C2 and C3, C parallel is equal to 1 plus 1, that is 2 microfarad. Therefore, we come back to this formula and then C equivalent can be written as 1 over C1. Now we have this capacitance plus 1 over C parallel, what we calculated here. So this is basically the series combination of this single capacitance and this single capacitance. Therefore, C equivalent will be determined after plugging the values of C1 and C parallel as 1 over 1 microfarad, which is the value of C1, plus 1 over 2 microfarad, which is the value of C parallel. So therefore, the net capacitance of this complete network is 1 over 3 microfarad, that is equal to 0.33 microfarad. Now, there is a very interesting question for you in the form of a quiz. You are given two capacitance, that is C1 and C2, which are clearly shown in parallel to each other because both the ends of these capacitors are connected at the same nodes. And in series with this network, you have another capacitance that is again given as, let's say this is C3. And values of C1, C2, and C3 are given as 1 microfarad each. Now, you want to calculate or determine the equivalent capacitance of this network looking from this end. So try to use the formulas given earlier and plug in the values and calculate your values and write the answer in the comment section of this module. If you like the module, share it with others for a wider reach. Till then, stay tuned for more informative content on the microelectronics and nanotechnology like this. Till then, wish you a very happy learning.